Over to Mr. Ritesh.
Thank you so much, sir, and congratulations to the club for celebrating its silver jubilee. Today it's my pleasure to introduce the first speaker, Ayush Prasad. Ayush is a 7th grader at the Oak Ridge International School, Hyderabad. Ayush has always had a keen interest in topics related to STEM as well as humanities from a very young age. He is an alumnus of prestigious STEM programs, including the program in Algorithmic and Combinatorial Thinking by Professor Rajiv Gandhi from the Rutgers University, the Epsilon 2023 and 2024 camp, Stepping Stones, organized by Dr. George Thomas, who did a course with Ayush. And Ayush has also been an invited speaker at the Rotary Club of Coimbatore Metropolis and 41st Club and the like. Ayush also has a YouTube channel called the Funtastic Academy, where he loves sharing his knowledge on mathematics, physics, and computer programming. Today, Ayush will deliver a talk on the mathematics behind how a machine can think like a human brain. Over to Ayush.
Good. Yes, so now we are curious, having listened to a nice and sweet introduction. So, Mr. Ayush, present yourself. I'm sure you know the time duration. Nominally, we'll keep 10 to 15 minutes, nominally. So, over to you, Master Ayush. Do you want to share the presentation?
Yes, sir.
Yes, you have to share the screen. Yes, then I will make you the host. Yes. Yes. Mr. Ayush, after you complete the presentation, you can remake the host to me. Okay? Fine. Over to Ayush.
Thank you, Dr. Tyagaraja sir, for giving me this amazing opportunity to speak at this club. It truly is a privilege and an honor to be here among so many learned mathematicians and the wider community alike. So today I'm going to be giving a presentation on how neural networks learning like the brain, the mathematics of neural networks. Now, this is a short introductory slide. Most of the things on this slide have already been covered by my father's excellent introduction. So I'll go to starting my presentation. Now, have you ever wondered in your day-to-day life how, say, a computer system like an Alexa can recognize your voice and follow its commands to do anything like play music? Or have you ever wondered how the new self-driving cars, such as Teslas or Google Waves, can recognize the environment and drive themselves? Or have you ever wondered how modern phones can recognize your own face and use that to unlock the system? Well, the answer to all these questions and many more applications in our day-to-day life are neural networks. So, what even are neural networks and what is all the buzz all about them? Well, neural networks are, just simply put, a type of machine learning model. That might sound complicated, but all it means is that it's a way for computer systems to take certain numbers as input and output a different set of numbers. They can take in a particular set of training data to learn from and study from. And using the training data, it can predict new unseen data and figure out what actions to take. Neural networks are used in a variety of fields. They can be used in, say, classification of data, such as recognizing a particular image. They can be used in predicting what will happen. For example, transcribing speech, predicting what you are saying. And they can also be used in actually controlling complex systems, like controlling a self-driving car based on the images that it sees all around itself. And the concept of neural networks was originally developed in the very famous paper published in 1943 by McCulloch and Pitts. And in this paper, they proved that essentially a neural network can replicate any possible logical system. So, how does a neural network actually work? And what is the mathematics that helps it function? Well, as you can see from this diagram, it's made out of neurons, hence the name neural network, and a neuron just holds a number. That's all it is. It's just a box that we put a number in, essentially. So a neural network will be made out of layers of these neurons. You can see in this diagram, we have three separate layers. We have an input layer, the numbers we feed in, the output layer consisting of the outputs that our neural network will provide us, and in between we have this hidden layer which allows us to do some extra computations. And each of these circles just represents a neuron, and you can think of each neuron as just having a number inside of it. So the result that each neuron has, the number that it stores, is essentially just an average of everything in the previous layer. So each of these neurons just takes an average. Of course, taking a simple average is not that interesting. So what we instead do is we take a weighted average. So a weighted average uses different weights or different amounts of concentration for each of these connections. So we might take twice of the weight for this node, 1 times the weight of this node, etc. And you can think about it as if we're taking this neuron, then this connection strength, the strength of the connection between these two neurons is represented by a weight. So for each neuron in this hidden layer and output layer, we have a set of weights going from the previous neurons. And so the output of a particular neuron is just the first weight times the first neuron plus the second weight times the second neuron, and so on and so forth. And you can see it represented by this equation. We also add a bias amount, B, just to represent some more complex relationships. Now, you can think of this as just a linear combination. In school, you might have learned about linear equations or linear combinations. So this is just a linear equation with the variables n1, 2, etc. But linear equations themselves are not interesting. We want more complex non-linear equations. In real life, the world has many non-linear things. Driving a car or recognizing speech, these are all non-linear things. So we can't just use a simple linear function to solve them. So that is why we use an activation function. And the idea behind an activation function is it's essentially just a wrapper function that you can use to give a layer importance. Activation functions don't have to be complicated, they can be very simple. For example, the common activation function used is called value. If the input you give it is negative, it outputs 0. If the input is positive, it outputs the same input that you have given. That is it. Very simple function. But using this activation function, you essentially give each layer an importance, and it essentially detects whether a particular neuron activates or it doesn't activate. And this allows a neural net to represent much more complex relationships. Now you might be wondering, how does this neural network actually learn new relationships? We have weights and biases and etc. But that is just essentially just a formula. How do we tune this formula parameters such that it can properly take the input into the output, such that it knows the proper relationships? So let's say we input a particular training data into our neural network, and we have this set of neurons, and
it's important even in gaming.
I can't understand
It's okay, it's okay. Just follow whatever.
Excuse me, hello? Yeah.
And sir, please turn off the mics except Ayush ji, so that it will be better for him. Jaskaran sir and other.
Thank you, sir. So, we are given this example of let's put some arbitrary training data that we want to learn from. And over here in one of the outputs, it's unfortunately outputting too much of a low value, which makes sense. We have just given it some random weights and random biases. It doesn't know how to actually figure out the values. So its outputs in this case an output that is too low. So ideally we want this output plus to increase by +1. Now this output is based on the values in the previous layer multiplied by the weights. So you can see I've just put some arbitrary values. So this output is based on this neuron times the weight plus this neuron times its weight. And we want to increase this neuron's output by 1. So the way we do that is we either have to increase the weights or increase the value of the previous neurons. And so you can actually perform a simple tools of calculus, essentially using a tool called a chain rule. You can figure out how much you have to update these weights and biases. So we might need to increase this weight by a large value in order to increase this output. This weight we will increase by a smaller value. But we want to increase these particular neurons. This neuron we want to increase by same +1. How do we do that? It's the same problem as we had before. Previous slide, we wanted to increase this neuron by +1 value. Now we want to increase this neuron by +1 value. So you can do the same thing going backwards through the network and finding how much you have to increase each neuron's value, and based on that you can alter and tune the weights until it outputs the correct values. And this going backwards through the network is called the backpropagation algorithm, because you are propagating backwards through the network. And we can repeat this for a lot of different training samples until when you get an input from the training sample, an arbitrary input, it provides the correct output value. And this is essentially how neural networks learn over time, by slowly over many training samples adjusting the proper values of the weights and biases going backwards through the network. Now at this point you've heard me talk for far too long, so probably you want to see an actual example of how one of these neural networks would work. So I have this slide here. This is a tool called Google TensorFlow. This is a simple web-based playground. Can you see what I'm presenting? You can see the website I have here, right?
Yes.
Yes.
So this is the simple playground with Google TensorFlow. It's a very nice website. You can choose the different data sets you might want to use. Let's say we use this simple data set. And we essentially are running a classification problem. So the problem is we need a neural network is given the x value and the y value of a particular point. This is a 2D space and we have an x and y values for a point. Based on that, we want to detect whether our point is in the orange set or the blue set. Now as you can see, initially our weights and bias values are completely random. So you can see that we just have a random divider which doesn't fit the data really well. Ideally we want orange value in the upper left and bottom right, and we want a blue value in the upper right and bottom left. But if I press this play button here, you can see over time the neural network will learn the pattern in the data set and it trains over time. So if I see, you can see how the neural network has adjusted all the weights and biases. You can see every layer and every neuron, and see over here it has learned properly how to tell the difference between the orange set and the blue set. It has successfully classified the data. And this is how neural networks work essentially. The values from each layer feed forward into the next layer's values, and we adjust each of these weights and biases in the connections until it has learned properly, which is what you can see here. Now what I presented to you is only the most basic type of neural network called a feed-forward neural network. That is because we are starting in the backmost layer and feeding forward the values to the next few layers. There are many different types of neural networks. For example, there is one called a CNN, a convolutional neural network. And what this uses is essentially image filters. You might have heard about a blur filter or sharpening filter in the photo editing app. It essentially works the exact same way. It uses many different filters in the neural network to identify patterns in an image. Let's say I can develop a filter will identify whether there's a vertical line or horizontal line in an image. Then I can use filters upon the filters. So I can make a filter that identifies, is there a vertical line here, horizontal here, and that's a rectangle. So I can use these higher order filters to identify complex shapes like a rectangle, and after third or fourth order filters, potentially you could recognize some complex structure like a human face. And that would be how a neural network could identify faces or particular objects and images. Another neural network is called a transformer. You will have heard about ChatGPT, right? I think everyone in this audience must have heard of ChatGPT in the last year. The T letter in GPT, the T letter stands for transformer. And a transformer uses a mechanism known as the attention mechanism to find deeper word meanings. For instance, if I have the word mole in my text, you do not know based on just the word mole whether it is mole on your face or mole the animal or mole from physics class. But if I have a word next to mole, for example, burrowing mole or facial mole or Avogadro mole, based on those nearby words, you can adjust the meaning of the word you already have. And this mechanism is called the attention mechanism, and it is used in transformers, and that is why transformer tools such as ChatGPT can write text very well. So thank you for listening to my presentation. I am now open to any questions from the audience.
Any comments?
Yeah, his lectures seem to be, on neurology basics for doctors rather than, students. So I heard some students, not understanding because neurology is a subject of advanced level, So neurons are used and basics in that. That is what I could make out. How mathematics is used. We know that a lot of mathematics is used in medicine, and that is a good example.
Any more comments, please?
I have a question.
Yes.
Ayush. So you were talking about neural networks. Isn't all those neurons in our brains and in our body? How does that relate? At the start of the presentation, you said, how does AI even recognize our faces? How does this link to the AI? Not just like how you said our phones can see our faces and open.
So as I mentioned, this is actually inspired by the structure of neurons in our brain. That is why it's called a neural network in the first place. It's inspired by the structure of neurons in our brain. And as I mentioned before, this seminal paper by McCulloch and Pitts proposed a method where mathematically you can use formulas in a computer to replicate how our brain would learn, and they showed that this similar formula that they just guessed how their brain would work, a similar formula could hypothetically, they mathematically proved, could represent any statement in logic. So this has been developed over time by many researchers in biology and computer science, and we can use these neural network structures in our systems, computers, to replicate how real learning would work and how systems would learn relationships over time.
Got it. Thank you.
Good. Good question and good answer.
Yes, first of all, at that age, he has presented something which is unbelievable. Only those who have experienced can understand that. Thank you, Ayush. I shall introduce your YouTube channel to many maths enthusiasts in my academic circles. Then just for my understanding of face recognition, now, neural network, the name is because of the way in which things function in the brain, and the mathematics, the probability, all these things, they use these in the programming, in shuffling different values and finding what is the best thing that can match the expected output and go on converging things. For that, lot of mathematical process is involved. I think that may be. And regarding face recognition, totally I am not in that kind of area, but what I feel is from my civil engineering background, when I am seeing those grid diagrams, network grid type of diagrams, if one face is denoted by number of points, and if I can know the 3 coordinates of each point, then I can redevelop the surface topology of the face. Then to that, some texture, etc. All these things, I think over the time people have converted into mathematics, and then they are developing these things. But it's only my guess. I don't know whether I'm right or not. Thank you.
Well, actually, so facial recognition algorithms work in basically the exact way that you've described. So they use a neural network to, given a particular image of a face, find out the x, y, and z coordinate of any particular feature of the face, such the coordinate of the nose or the coordinate of the temples. So like that, you figure out the coordinates of each important feature of the face, and based on that, as you can say, you can reconstruct the topology or reconstruct the 3D feature of the face. And since most people's face will be very unique, you can use that to identify whether 2 people's faces are the same or different. And as you mentioned about the mathematics of it, I would say I glossed over quite a bit in this presentation. But for someone like a civil engineering background like you, it's essentially just basic calculus using the chain rule, figuring out essentially what would be the derivative of a particular weight compared to the error. So if I know that increasing this weight value will increase the error by this much, I can use that to figure out how should I change the weight to decrease the error. So it's essentially boils down to finding the derivatives of each weight and bias with respect to the error of the network, so we can reduce the error.
Excellent. Ayush, for the benefit of the friends who may not be very familiar with neural networks, shall I give an introduction about it in 3 sentences? Is it a good idea, Ayush?
Maybe.
Okay. Yes. So I am putting it in simple words. Original way of computing was a sequential programming. By sequential programming, if you want to recognize any image, it used to be extremely complicated and extremely slow. this sequential programming was not suitable for image processing. But a human mind can do the same thing in a fraction of a millisecond. People wondered how is that human mind is able to look at the images and process the images so fast. So taking this as the cue, they studied how the neurons in the brain work. What is the mathematics going on behind the neurons? So here all the neurons are working in parallel, not in sequence, and the neurons are getting connected in real time to process the data very quickly. So people have realized that this is the most important method of doing fast computing to process the images and further any such faster applications. So emulating the structure and functioning of neurons, they started preparing mathematical algorithms. So that's how neural networks came into existence. It is basically emulating the brain. Now using this, now it becomes a best tool for artificial intelligence. Basically the human intelligence is replicated artificially onto electronic circuits and into electronic programs. Essentially, this is about how neural networks help in creating artificial intelligence. Okay. Now a comment about Ayush's talk. Ayush has demonstrated unusual understanding about the functioning of neural networks. I could not find this kind of understanding from several sources. This is something which we have to appreciate and give a big hand to him. This is an unusual understanding. He explained as to how linearity is not so interesting, how to bring about a non-linearity, and what is the use of weights, and what is the use of this additional function which he has given, how a function, an additional function can actually bring in the required non-linearity. These are all superb insights about neural networks. What I would suggest is his parents can help him in this. He can write a booklet on basics of neural networks for pre-university students. This will be of great help. Basics of neural networks for pre-university students. With this title or near about this title, he can attempt a book maybe of 50 pages or between 50 and 100 pages. That would be greatly useful, and I personally congratulate you for your such clear understanding about neural networks. Any one more comment from the friends in the audience? Otherwise, we shall go to the next one.
So just
The next
a quick
topic.
comment. So as you said, just I'm continuing. So he is not actually a child. So he is, I think, level of undergraduate or postgraduate level. So that's what I think.
Yeah, he passed only 7th standard and he is going to 8th standard. His age is of 6th standard, 11 years.
Yeah. So age doesn't matter. That's
His makeup, his mental makeup is quite advanced, and
so I was looking his presentation skills also. So it is actually well matured presentation skills. That's what I'm looking. He is not up to that 10 to 11 years kid.
yes, while presenting, he was able to read the mind of an audience and explain accordingly. That sense could be seen in his presentation. Am I right, Dr. Govind?
Yes, sir. So it's actually online experience. So maybe people will not be able to see all his skills, but in offline presentation, it was actually very more glowing than online presentation.
True. He demonstrated that kind of talent of speaking to the audience. That's very excellent thing.